Interesting, I got a email from Chris Lounder in Nashville saying that customer says that the nuts on their flare fittings keep backing off. And that's actually not what's happening. And this is something that we addressed as far back as 2003. So this is for the advantage of the Nashville branch, but also for you others. I wanted to talk to you about the importance of proper PFA flaring. First off, we're talking a little bit about your origins. Flare fittings came out and people are saying, well, that's all fine and dandy, but how do I get that on there? Frank Hayes, the wizard of Fitline, came up with this idea, and I think a lot of you guys around PFA tubing have seen this. And Frank designed this with this Teflon mandrel on here and actually got a patent on it. And we sold tons and tons of these over the years. And essentially you push the tubing onto that rascal, and then if you're big and strong, you start pressing it like a pair of pliers and you move the tubing around and you keep going and you try to, got the handles I got there coming off. You keep going on this darn thing and eventually you get it big enough to where you can get it up over that. But essentially you're cold flowing the tubing. You're mechanically stretching the tubing to try to get it to eventually go over this. Well, that was fine for a few years, and customers were saying, well, we're getting leaks in our system and we really don't think that's a good idea. So then the next thing came up was somebody says, well, why don't we make something that looks like a flare, flaring mandrel, and we'll heat the tubing with a hot air gun, which I happen to have here. And so if I didn't, on a Monday, if I didn't have too many tequilas last night, hopefully I'm in good enough shape that I can do this. And actually, as I do this, this cold flare that I started to do will actually shrink back because there's enough material memory that the tubing wants to return to its original shape. So if I didn't have too many tequilas last night and I'm not too hungover, maybe I'll heat this tubing for 20 seconds or 30 seconds or maybe 45 seconds, I don't know. Maybe Jerry over here will do it for 30 seconds. Maybe James, who's filming this thing, will do it for 25 seconds. There's really was no ever rhyme or reason on how to do this correctly. And so I've heated the tubing. I'm gonna try to push it on this mandrel, and I did get it hot enough, and it will flare out the tubing. Incidentally, these Teflon mandrels, instead of buying them from Parker or St. Gobain or Integris, buy them from us. We machine them in-house. They do come with this stainless stud and handle, and the handle's removable, so if you want to mount them on a flat table or something else, you can do that. But anyway, they're cheaper if you buy them from us, and we've got complete sets, 1/4 through 1.25 inches. You can either buy them one at a time or you can buy just one. So this is still kind of warm. The other part of this particular process is you got to wait for this thing to cool enough. But essentially, when I pull this off, you can see you got kind of a bell pattern that kind of resembles the flare, and most likely I can get that over, and I can. But what happens is the engagement right there on that bevel of the flare nozzle is supposed to fully engage the bevel on the inside of the flare. Well, you can't do that because flaring tubing like this doesn't allow for that. So Frank Hayes and I designed a flaring machine, which we're looking at here, the FT4, and introduced it to the market back in, I think, 2003, and also did some testing. What this does is we've got this set at 285 degrees centigrade, which essentially is below melting point, but above the temperature where it'll actually change the material memory. So if I put this in the heater bushing it turns a timer on that starts 35-second countdown and actually gives us a precise heat soak time versus Paul sitting there with a heat gun, and I do it different than Jerry does it, and different than James does it, and whoever, and is precise and repeatable every time. And then with this kind of a flaring process, of course, what we're doing is, all we're doing is trying to push the tubing out like this. And what this tool does is simulate something that's closer to what injection molding would be. Injection molding, you're taking molten material, and you've got what's called a core pin, and then you've got clamp halves that are called mold. And that's going to form both the outside and the inside of the tubing. And that's what we're going to do with this machine. Now that that tubing is nice and hot, I'm going to clamp it down, and I'm going to push that flare nozzle, or I'll call it a core pin, in there. And this starts a cooling cycle that is, again, is precise, it's repeatable. It doesn't change, it's always the same. And of course, way back in 2003, we tested all of this to make sure that these parameters were correct. So we're going to give this a little bit of a countdown. And then I want to, while that's happening, I want to talk to you a little bit about the term cold flow. So we started with cold flaring, we talked about heat gun, and now we've gotten to actually a flaring process that is more of, you can see how that looks different than that. That's the key, because the way flaring was designed, the patent that was written way back in, I think, the 60s, said that the engagement was important at that point. Why is it important? When they extrude tubing, when they make this tubing, it's extruded with a resin that has a property called melt flow index. With tubing, it's not real important. They can get the resin to a molten stage, goes through a tubing extruder. The melt flow index is typically somewhere around 12 to 15. That with something like this, with an injection molded fitting, with all these little tiny details, the fine thread flares and all of this, you've got to take that same molten PFA, get it through the entire mold cavity before it gets cooled. And so they use a melt flow index. It's a lower number. It's typically somewhere around 3 to 5. What those numbers mean is, as the number goes up, material gets harder or stiffer. So tubing, again, 12 to 15, is much harder material than fittings, 2 to 5. So if I have a flare that's not formed very well, and I put this on there, and then I tighten the nut down, I'm actually taking a stiff material and forcing pressure to get this to engage properly at the flare level. Whereas if I have a fully formed flare that goes on like that, I'm not trying to deform the tubing. And essentially, as I'm deforming the tubing, guess what I'm doing to the softer material? I'm deforming the fitting. So now you put this in service. In most services, if it's regular ambient temperature and never changes, no big deal. But in Chris Lounder's situation with his customer, they have thermal cycling. This gets hot, and it comes back down to ambient temperature. And it gets hot again, it comes back down to ambient temperature. And cold flow is that property of, if you ever take a hose clamp off your radiator hose on your car, there's that perfect indentation of that clamp that goes to hold your radiator hose in. If you take your wedding ring off of your finger and you've got an indentation on your finger, it's cold flow. Essentially, you got a harder surface that is moving against a softer surface and getting it to deform. So in a thermal cycling with a not very well-formed flare, it's going to continue to push on the softer material. The softer material is going to cold flow away from the mechanical resistance. And what's going to, that fitting nut is loose. And so what do? You go and you crank it down. and basically it exacerbates the problem. Eventually the flare will fail. If you use a fully formed, proper flare, then you won't have those kinds of problems. And I'll show you one other thing before we sign off here about flaring that's very, very important. When you use the cold flaring pliers, you're stretching material. When you get it up to almost fully molded temperature, and then you form it and change the material memory, you get a cross section that looks like that. You can see that the angulation is exact, and also guess what? There's no thinning anywhere in the wall. We are not shrinking the material, we're actually remolding or reforming the material. So it's very important to get, there are different systems. SMC makes HyperFlare, of course, Pilar makes S300. We now have Nexus available through Fitline. So there are other methodologies, but SMC's HyperFlare isn't necessarily better than standard fine thread flare. It's really about the mechanics of making good craftsmanship and using good flares. So that's my message for today, and hope that's some value to you.